welcome everybody. It's really lovely to see you all today. We're here, the RDS team. For those of you who haven't met me, I'm Nikki Zimmermann. I'm the lead of the direct support services. And
I'm Seb Crutch. God, very loud, Seb Crutch.
Almost as loud as me.
I'm a professor of neuropsychology and the clinical lead for RDTalk.
And the agenda today, we've got hopefully a really nice mix for you today. We have Dr. Keir, Yong and Yuhan talking about their research updates and some more understanding about PCA. I'm very pleased that we've got our special part of the day, which is our members' experience, and we've got Chrissie and Nick here today, who's going to talk about keeping socially engaged. You may come away from this feeling very jealous, because I do, and I really need to get my life sorted out, some new friends, and start using my passport a bit more afterwards. I always think this is a lovely sort of motivational part of the day. Karen's then going to join us to talk about the peer support groups that we run, and then Ollie is going to talk about some of the research opportunities that we've got with the RDTalk project. I know a lot of you have already been involved, but to any of those who haven't been involved yet, Ollie will tell you more about that. And then after lunchtime, I'm delighted that Prof Jonathan Schott will be joining us to talk about some clinical updates. Many of you will know John from the clinic, and he's always got really keen interest in PCA, and really an added bonus for us when he can come along to our sessions. And then after that, we'll have a Q&A session, and we want a really nice interactive session of asking questions, and then we're going to help with sort of interventions that you'll share yourselves, but we can share on a sort of support basis and a clinical basis as well. So hopefully that will be a really nice way to finish the day. I will shut up in a minute so I can bring some good work. So just a little bit of an update of where we are. We are well on our way to 8,000 members, so considering we've got a very small team, 8,000 people all over the UK and internationally, is quite a large number. And out of that, we've got just over 1,800 people living with PCA or caring for somebody with PCA. So as I said, we've got 80 people here today, but that's just a small fraction with the larger sort of cohort we've got. All of our meetings that we do, that we record, if you want to have a look at them afterwards, or go back to see ones that we've been doing for several years now, they're all on our RDS YouTube channel. So please do dip in and have a look at those. Like I mentioned, Karen's going to be talking about the peer support groups, but we actually do 18 peer support groups each month now. So hopefully we are providing a space for you, not only in person, face-to-face here, but online to meet other people in similar situations. Ollie will be talking about the research opportunities through RDTalk, but also Keir and Yuhan are here as well. So if you are interested in any sort of research, I'm sure they'll be happy to speak to you as well. I'm just going to hand over to Seb now, who will just mention the RDS Centre.
Yes, if you've been to one of our meetings before or have seen any of our emails, you'll have known that for the last few years we've been trying to find a home for the Rare Dementia Support Service, and we're really delighted that we are finally getting properly close. We've finished our fundraising thanks to the National Brain Appeal, a number of major donors, and including some who are here today. We've secured some buildings, the builders are in, and they plan to hand over the building to us, this new home for the Rare Dementia Support Service, in December this year. So we're hoping this will be the last annual PCA meeting that will be here at Quorum, who've been very kindly hosting us for the last few months. And we hope it will create a much more intimate, homely space for you guys to come together, not just once a year in person, but much more often than that, in smaller groups, in family groups, in one-to-one settings, so to create many more opportunities, both to understand more about your condition, to make friends and connections with other people in a similar situation, and also to share what you've learned along the way to help other people who are somewhere along their journey as well. So a huge thank you to all of you who've been involved, shown interest, and yes, watch this space, and particularly watch the map the next time this meeting invite comes out, because you won't be coming hopefully to the same place. Okay. Just before we get started with the meeting, there's lots of excitement in the agenda today. There's quite a few talks, both about lived experience, science, clinical aspects, but we don't want to take anything for granted. So we thought just one slide before we get. Some of you may have had a diagnosis very recently. You might be here with a family member and not actually feel confident telling your friends and family what PCA is, or you might just want a bit of a refresher. So PCA, or posterior cortical atrophy, which literally means back of the brain shrinkage, is a syndrome. It's not a disease in its own right. It's most often caused by Alzheimer's disease in about 90% of people. But it's a syndrome where, because of changes in the cells at the back of the brain, healthy information coming in from the eyes is either interpreted differently or misinterpreted. And that creates problems often with things like seeing what and where things are. That's often what people complain about first, but it's not always the case. It's quite a heterogeneous or a condition that affects people differently. So some people start with really clear-cut spatial problems, perhaps noticing a loss of confidence driving because judging distances has become more difficult, or misplacing items, or finding it really difficult to do tasks at work, like using a computer or typing emails, or words dancing around on the page when you're trying to read. For other people, it seems to hit a slightly lower part of the brain, and that affects often object perception first, so people noticing that they're having difficulty recognizing what things are, particularly under difficult or low lighting conditions. Sorry, am I drifting away from the camera? I'm so sorry. The TV producer in Sidra is directing me back towards as I drift away. Sorry about that. So some people have object perception problems, and some people it doesn't have a kind of clear-cut visual kind of story in the same way. Lots of people describe more problems with things like reading and writing. Arithmetic might be difficult, doing complex things with your hands, using tools, that sort of thing. But these are all skills which we know are kind of fundamentally dependent on the back of the brain. And so when that's impacted, as shown in the bottom picture, the hot colours at the back of the brain are the bits of the brain that are most affected when we look at the brain scans of people with PCA who've kind of taken part in research. Just in case you've never met anyone with PCA, it's unlikely in this room, but I thought I'd just show you one very quick video that we often share, which is someone who kindly volunteered to take part in an educational programme for eye health specialists to try and describe to them what PCA is. Let me see if this will work.
I want you to look at my nose. Look at my nose. I'm going to put my hands out. I'm going to move my hand. And if you see my hand moving, can you reach and grab it? My nose. There you go. Got it. Well done. Look at my nose. Look at my nose. Let me find my hand. Can you see my hand moving?
No, I can see your nose.
Can you see a hand at all? See my hand moving?
Is that keeping my...
Yeah. Keep looking at me. Can you see my hand moving? Can you see my hand moving? Can you see my hand moving?
Yes.
Grab it for me. Where is it? Where is it? You got it?
God, where is it?
You'll find it in a minute.
Wow.
Very good. Okay.
This is very weird. So you were just hearing the voice of the legendary Jonathan Schott, and play the video and he shall come. I promise we didn't time that. I didn't set that up in advance. So what you see there is incredible good humour from someone who is being asked to do something that he understands the task perfectly well. His eyes are fine, but the cells doing the computations in the back of his brain that do left, right, up, down, near, far, those sorts of judgments just aren't working in the way that most of us take for granted when we reach out and grab a cup of tea or whatever it is that we're trying to reach for. And it's those sorts of experiences which it's kind of easier to get when you see it with your own eyes. but it's quite hard to talk about. And that's one of the reasons why it's so important for you guys to talk to each other, and why we're so appreciative of you being here today with the questions that you'll ask, the experiences that I hope you'll share, because you will have ways of putting it that kind of click and make sense to other people here in a way that conversations with others who don't know about this condition may leave you feeling isolated and as if you're the only one who's ever had this thing. So please do talk and share today. One quick example, one of the most common symptoms that defines PCA that you see in the kind of medical diagnostic criteria is a thing called simultanagnosia. Put up your hand if you've ever heard that word before. Exactly. I guarantee you there is no one sat at home who's been through what you guys may have been through, of maybe having several years of just things just not being right, losing confidence with things that you used to be able to do without a second thought becoming much, much more challenging. No one sat at home waiting to go, oh, yeah, simultanagnosia. I need to go and tell my GP I've got simultanagnosia. Simultanagnosia means a difficulty seeing complex objects or scenes, or seeing multiple things at the same time. But it's hard unless you've experienced that, or you hear someone else who's been through it describe it. It's quite hard to capture what those words are. But you guys have the phrases. I was going through a piece of our research today, analysing some feedback some of you had kindly given us, and someone put it much, much better than the term simultanagnosia. They said, I feel like, what's changed is I now use a TV like a radio. I was like, that's the best definition of simultanagnosia. Your understanding, your language, your memory, your ability to follow a plot, all fine, but these complex images dancing around on the screen, that's what's become difficult. And so it's those sorts of phrases that you share with each other today, that are cascaders who are out around the country giving talks about their lived experience of these less common forms of dementia. That's what makes the difference. That's what raises awareness. That's what will hopefully mean that more people will get the diagnosis they deserve, and hopefully without some of the struggles that some of you have had. So please do keep talking today, but also, if we've taken anything for granted, if there are any jargon used, please just pause, because you won't be interrupting us, you'll be helping someone else in the room who's also going, what's that thing mean? So interrupt, make it interactive, don't be polite, and make it what you need it to be. Thank you so much for being here, and this is my cue to hand on to Keir and Yuhan, who are going to come and give you our first talk about some research updates. Thanks.
Great, thank you, Seb, and great to be meeting some people here in person today and seeing some new and familiar faces. So, my name's Keir. I'm a Dunhill Medical Trust Senior Research Fellow. I'm Chief Investigator for the UCL Study of Posterior Cortical Atrophy, or PCA, the Etherington PCA program. So, it's fair to say that there's been a number of quite major updates in the past year. Again, this is the PCA annual seminar. Perhaps one particular historic update has been the approvals of so-called disease-modifying therapies. By this, you can think of these essentially as being treatments where there's evidence they slow the rate of clinical progression by treating the underlying pathology that causes these clinical symptoms. And while I'm happy to take questions on this topic, as you've just noticed, we've been joined by Professor Jonathan Schott, who is a consultant neurologist, and he's Alzheimer's Research UK Chief Medical Officer, amongst other roles. And without throwing him under the bus, he's already presenting this afternoon. I think he's really uniquely placed to talk to the topic of emerging treatments. What I'm going to be doing instead is particularly focusing on research to better understand some of the biology underpinning PCA. Myself and Yuhan are also going to provide some brief updates on research to improve PCA diagnosis and support. Now, I just want to forewarn you of a couple of things. So much of the first part of my presentation is going to be very biology focused. So that is focused on the analysis of proteins and of brain cells. So I apologise sincerely in advance if at points this feels dispassionate. I understand the sensitivity of this topic, and I also understand completely if people would rather leave this part of the presentation or ignore it entirely. Now, relating to this caution, I myself am not a pathologist and I'm not a clinician. The work that I'm going to talk about was led by Dr. Zainab Abdi, so this is part of her Alzheimer's Society funded PhD. So Zainab's a neurologist who was working between the Queen Square Brain Bank and the Dementia Research Centre at UCL. Now, this is quite a poignant topic for various reasons. One of them is that Zainab herself was presenting at one of these meetings immediately before COVID, where she was inviting feedback from support group members on her proposed PhD. And in the following years, she spent them painstakingly conducting pathological analyses of a group of people, 26 people with PCA, and a group of 27 people with what we might consider as more typical memory-led Alzheimer's disease. I'd like to know that these groups were of similar age, sex, and on average they were about 10 years after the onset of their symptoms, so they might be considered at a relatively late stage of PCA or more typical Alzheimer's. So I'll be doing my best to briefly summarise her PhD findings, which were published just this month. Firstly, I'll talk about the comparisons of Alzheimer's disease pathology between this group of people with PCA and another group of people with memory-led Alzheimer's. I'll talk about similar comparisons of non-Alzheimer's disease pathology. And finally, I'll talk about comparison of markers of inflammation. So starting off with Alzheimer's disease pathology. As we just heard from Seb, there's some recent findings suggesting that perhaps 9 out of 10 people with PCA could attribute their symptoms or their PCA syndrome to underlying Alzheimer's disease pathology. For this particular study, all participants had a primary pathological diagnosis of Alzheimer's disease. This is defined by the presence of these amyloid plaques. So at the top here, I'm showing an image of an amyloid plaque with an arrow pointed towards the dense core of the plaque, as well as these so-called tau tangles or neurofibrillary tangles, and that refers to the image shown in the top right. First of all, there was no evidence that the amount of amyloid or tau differed between PCA or memory-led Alzheimer's disease groups. However, for the PCA group of participants, there was evidence of particular increases in Alzheimer's disease pathology, and especially this tau pathology, in a part of the brain that's called the parietal lobe. And this elevated parietal tau can be seen here, indicated by this red marker. This is just showing tau for the PCA group in red. Now, this parietal vulnerability is something that's been documented before in PCA, and it fits with some of the symptoms that Seb's been describing. So these parts of the brain are particularly responsible for interpreting visual and other sensory information, which is particularly important for perceiving where things are and for guiding movements. Now, my colleague Yuhan will be talking a bit more in detail about some of these so-called functions or abilities. Now, on top of some of these findings, there were somewhat surprising results. Now, first of all, the amount of tau within the brain's so-called basic visual areas. These are right towards the very back of the brain. It's the first part of the visual cortex or visual brain which receives information coming from the eyes. So tau in this region didn't appear to clearly distinguish people with PCA from people with more memory-led Alzheimer's disease. Now, instead, parietal tau, which is really at the top back of the brain, was accompanied by the build-up of tau at the top front of the brain, and that was especially apparent for this group of PCA participants. Now, as mentioned, these are somewhat surprising findings, and in the interest of time, I'm happy to talk about these in further detail and potential interpretations in the Q&A. Now, moving on to non-Alzheimer's disease pathology. Now, there's been increasing recognition in the past years that having not just one but multiple underlying pathologies appears to be the rule rather than the exception for people with common age-related neurodegenerative conditions. One recurring question in the research community has been whether the differences that we see day to day between people with PCA and people with more memory-led Alzheimer's disease could perhaps be explained by differences in co-occurring pathology or so-called co-pathology. So Zainab assessed some of the pathological hallmarks of Lewy body disease, that's shown at the top here, as well as something else called TDP43. Now, these proteins are particularly associated with dementia with Lewy bodies or forms of frontotemporal dementia, respectively. Now, overall, the additional presence of non-Alzheimer's disease pathology didn't appear to convincingly distinguish the group of people with PCA from the group of people with memory-led Alzheimer's disease. Now, there's somewhat modest and mixed findings here. So, for example, while on average, there was a higher prevalence of Lewy body disease pathology in the group of people with PCA, actually the severity of this pathology didn't appear to formally differ between the two participant groups. And on the opposite side, in the memory-led Alzheimer's disease group, nominally there was slightly more severe TDP43 pathology in people who had a memory-led form of Alzheimer's disease compared to people with PCA. Now, moving on to markers of inflammation. Zainab then focused on microglia. Now, these are cells that could be considered the brain's resident scavenger cells, which are responsible for a range of different functions and something that's called phagocytosis. So Zainab explained phagocytosis to me as really these cells chomping up and clearing pathology. At the top left here, I'm attempting to show a video of a cell during phagocytosis. So what this is showing is a cell really engulfing or enveloping some pathology to then enable it to be cleared from the brain. Now, at the bottom here, I've shown a picture of a microglial cell. So this is just a cell which is at rest. And this is relevant given how microglial cells are very diverse in their functions and their different states. Upon detecting a threat such as the Alzheimer's disease pathology I've shown at the top of the slide here, they become activated and they lose this branched appearance that can be seen at the bottom, and their cell body increases in size. Now, in the PCA compared to the memory-led Alzheimer's disease group, microglia overall were more activated, and that was across the brain. Furthermore, pathological measures of the cell's ability in chomping up pathology were higher in people with PCA compared to people with memory-led Alzheimer's disease in a part of the brain that's referred to as the temporal lobe. Now, furthermore, this temporal lobe also happened to have the highest tau load in the memory-led Alzheimer's disease group, being slightly elevated compared to people with PCA. Now, this is important given how this temporal region tends to be one of the regions which is characteristically most vulnerable to Alzheimer's disease in general. Zainab interpreted these findings as suggesting that for people with memory-led Alzheimer's disease, their microglial cells might become overloaded by tau in this region, perhaps being something called senescent, which could be referred to as these cells becoming sleepy, having chopped up and cleared this pathology. Now, instead, for the PCA participants in general, their microglia might have been better organized or perhaps hypervigilant in being able to clear pathology from this temporal lobe over a sustained period. Now, what do these findings actually mean? Now, first of all, they emphasize the presence of amyloid in both PCA as in more memory-led Alzheimer's disease, and they suggest that non-Alzheimer's disease co-pathology plays at most a limited role in influencing why some people have particular PCA symptoms. They provide evidence of differences in regional tau, again tau being one of the two hallmark pathologies associated with Alzheimer's disease, between people with PCA and people with memory-led Alzheimer's disease. And these differences in, again, regional tau can be observed even a decade after the onset of symptoms. Now, this has implications for better understanding regional resilience and vulnerability to pathology, and in particular tau. These findings also provide the strongest evidence to date of differences in inflammatory response between a group of people with PCA compared to people with more memory-led Alzheimer's. Overall, these findings are relevant to so-called anti-amyloid therapies. I've shown as an example this amyloid plaque at the top here. And these therapies have received approval to treat what's referred to as early-stage Alzheimer's disease in the United Kingdom just in the last year. On top of that, these findings are also relevant to therapies which are targeting tau and other emerging therapies which seek to alter microglial function or activity. Now, there's a few caveats to bear in mind for this study. First of all, it involved a relatively small group of people with both late-stage PCA and late-stage memory-led Alzheimer's. Now, as we know here, not everyone with PCA is affected the same way by the condition, and consistent with this, there was some variability between participants and there was some overlap between groups. Relating to this caveat, the implications of this study for the level of individual participants is at this point unclear. And perhaps most importantly, not just based off this study but other emerging research, there doesn't appear to be a straightforward relationship between inflammation and Alzheimer's disease pathology in general. For example, unfortunately, it doesn't appear to be as simple as more or less microglial activity is good or bad. Realistically, the timing of the immune response to pathology and to other types of cells is likely of critical importance. But for a take-home message, it's fair to say that this study offers some insights regarding how and why Alzheimer's disease pathology may affect different people in very different ways. And they received some coverage in international news with one headline presented here. Particularly given the complexity of findings and their implications and perhaps the march for identifying new treatments or combination therapies, myself and others here are in touch with international experts in inflammation in the United States and also at UCL Department of Neuroinflammation. Now on this note, some of these collaborators include neuro-ophthalmology clinical leads who specialize in inflammation of the visual system. These neuro-ophthalmologists are supporting a 4-year study to develop dementia site care pathways in order to improve PCA diagnosis and care through better work across eye and neurology clinics. So this study is incorporating a so-called test of our brain site rather than our eyesight. This is a test that we've made for UK Biobank, and to date it's been administered to over 30,000 people across the UK, with some locations shown here. Now for all these participants, they've undergone repeat MRI scans and provided biological samples. And I'm showing this as an example of a study which complements some of the more detailed work that's been conducted at a UCL biobank, but to better understand factors associated with back of the brain vulnerability at a national level, that is in UK Biobank. If people are interested in hearing more about the study and just discussing research in general, I'd like to encourage you to speak with myself and Yuhan. Just to emphasize again, even the previous work really originated from conversations and support groups such as these. On that note, I'd like to hand over to Yuhan, who'll be talking about research regarding altered spatial awareness arising in PCA.
Thanks, Keir. I wonder if this works. Can I maybe use this?
You try, if it's loud enough for people, but shout if it's not.
I think it might not work as effectively. Can people at the back hear me? Okay?
Yeah.
It's all clear? Okay. And yeah, if people can't hear me, then just let me know. So Keir has just given a really good summary about PCA research in terms of the biological and pathological side of things. Now I would like to switch gears a little bit and zoom out from all that microscope and talk a little bit about where we've got at in terms of understanding PCA symptoms in the past years and what's our plan in the future years. So when it comes to Alzheimer's, people mostly associate it with memory problems, language difficulties, or even personality change. However, as many of us are better aware, Alzheimer's can also be associated with other stuff. For example, someone can have challenges in visual perception, spatial awareness, or navigation, especially in the dark. Our lines of research are particularly interested in these symptoms and are heavily informed by participants' reports. For example, some participants may report particular problems with dressing, especially when trying to reach for the other sleeve when putting on a jacket with one sleeve on. Some participants also report problems with reaching and grasping objects, and they would report needing to deliberately look at the object and pay attention to it so that they can conduct action smoothly and accurately. Indeed, our brain uses information coming from different senses like vision, hearing, and touch to make the best sense of our world around us, so that we can conduct actions that's accurate, smooth, and safe. And evidence suggests that these processes might get disrupted or changed in PCA, and we attempt to understand this better in the lab setting. So we use this task that's informed by something that all of us do in everyday life. Imagine leaving for this seminar this morning from your home. Imagine grasping your key, and you might have, through your desk to the door, you might have passed on your key between your hands multiple times, so that you have your other hand free for the task at hand or the task in front of you. And we do this sort of passing on keys action rather automatically, without needing to deliberately look at our hands, but then we can locate them relatively easily. We're curious in investigating whether this process is becoming less automatic and more deliberate in people living with PCA. So we designed this task in lab that, in order to better illustrate, I would like to invite everybody to participate with me. So I would like you to raise your left hand, thumbs up. Great. Now I would like you to use your other hand to tap your thumb. Great. Now I would like you to close your eyes and use your other hand to tap your thumb again. Right. Open your eyes. How do you feel? Right, so you might have noticed that the latter task is slightly or significantly more difficult than the first task, and that is expected for absolutely everybody. That's because vision is one of the most important senses that we use to locate where our arm is, and when vision is removed, our brain is actually not that accurate in locating where our arm is. That is what might explain why we might find grasping that glass of water on our bedside table particularly difficult at night as compared to in bright daylight. And it might also explain why we sometimes misplace our hands during a yoga workout session if we don't have a mirror to correct ourselves. So we did this task with our participants, and based on some previous research, our brain is indeed less accurate in predicting where our arm is, especially without vision. Indeed, our brain actually would estimate our left hand to be more left than it actually is, and our right hand to be more right than it actually is. We were able to replicate this finding in all of our participants through this task where everybody perceived their left hand to be more left than it actually was. What is interesting is, for the participant group living with PCA, this error was not only present, but 3 times bigger. So imagine a control participant exhibited a 2 centimeter error in perceiving where their arm is. An equivalent PCA participant would exhibit a 6 centimeter error in estimating where their arm is. We did something similar without vision. And as expected, everybody performed a little bit more inaccurate in the task, perceiving their left hand to be more left than it actually was. And what's interesting was, for the PCA group, instead of perceiving their left hand to be more left, when vision was occluded, it seems that they perceived their arm to be centered toward themselves. One possible explanation for this was the direction of the participants' eye gaze. And academically, we call this magnetic reaching, where someone's reaching trajectory is really dictated by their eye gaze direction, or where they're looking at. So So in short, we observed greater estimation errors for participants living with PCA when they are estimating where their arm is, and it could be partly explained by higher uncertainty in estimating where their arm is. And this it could explain some of the everyday symptoms that someone living with PCA might experience, such as pressing, such as reaching. And based on our further analysis, evidence suggested that this bias and this error can be due to that people living with PCA become more reliant on this thing called local references, which could be explained by gaze direction, joint position, or even how one posture themselves while sitting. These so-called local references can be good inspirations in making adaptations in everyday living environments to make it better suited for someone living with PCA. Some people in the support group meetings reported that using highlight stickers to stick on door handles or light switches helps people living with PCA to reach to that target. Some people also reported that using night lights really helped people to navigate in the dark. So that's a really brief summary of where we've got at the past years, and now I'm going to talk a little bit about our plan in the future years. So we want to further understand these processes that's still relatively poorly understood, and we want to therefore develop novel ways to assess and detect these disturbances in the perceptual processes to help better screen for these kind of cortical-related changes. We are currently developing a vision test, as Keir mentioned, that's screening for sight loss that's related to the brain rather than to the eyes. And we recently embarked on this novel investigation on one's sense of touch and how one can pinpoint the spatial characteristics of one's touch. I'm more than happy to elaborate on any of these studies in more detail. If you are interested, just feel free to chat to myself or Keir offline, and I'm very happy to answer questions. Yeah, that's everything I would like to report today. Thank you.
Well, I think we're on the right track because I've seen a lot of you nodding to what Keir and Yuhan said, so I'm glad we've got that right, so we're doing really well. So I'm swiftly going to invite Chrissie and Nick to come up and to see us. Would you like to come and join us, please? I'm going to give you this because I've got a loud voice. So have I. So for you then, Nick, do you want to come and stand in between us? There you go, you can be the rose between two thorns. Well, I'm really delighted that you've agreed to come and share your experiences today. And I think sort of the importance of having a diagnosis and living well is going to be very much demonstrated in this talk today. And I'm so pleased that you've sent me some photos and made me very jealous of what's going on. Was it? Yes, exactly. So if we start off, could you just tell me a little bit about yourself? Do you want to use this and talk into that? Yeah, you pop it to you now, there you go. So who are you?
I'm Nick, and I got PCA.
And where do you live, Nick?
In Axminster.
Axminster, yeah. And so you come to us, you come to our support groups, and you go to Karen's amazing support group down in Powder Castle as well.
Yeah, that's right.
Yeah, good. So, how long have you been diagnosed? When did you get your diagnosis?
That's exactly 3 years and 2 days ago.
3 years and 2 days, there you go.
And I would just like to say that we were very fortunate, if that's the right word to use. Nick was diagnosed within about 9 months.
Within 9 months.
And we didn't see any eye specialist. That was a neuropsychologist.
Neuropsychologist. Okay, so for
Just
a lot
out
of
of
people,
interest.
a lot of people that was quite a timely diagnosis.
Yeah. Okay. And so what? let's just say, what did we say? What did you say when we got the diagnosis? What did you say? What was the first thing you said?
It doesn't hurt me, and it's not going to kill me, so I'm carrying on as I always have been. And their motto is holidays, holidays, holidays.
I think we might see a bit of this. Are you guys ever in the country? I love that. I absolutely love that. Right, not finished yet. Quickly. So, what inspires you? Is it just your holidays? You must get up every morning, and do you want to do something?
Yeah. Yeah, something.
There's lots of things that, when people get their diagnosis, it's, when you can't do things, it stops you doing things, but that doesn't seem to happen. You seem to, I can do.
Yeah.
Yes.
So is it that can-do attitude?
Yeah.
And when you're feeling, if the weather's a bit off and you're feeling a bit down, you'll say, do you think we can go on holiday? So then I start looking, don't I? And then it's all systems go.
So, do you want to tell me a little bit about your holidays and talking to people on holidays? Do you ever share when you're on holidays that you've got a diagnosis?
Yeah. Yes.
But not straight away.
No.
When you get comfortable with something.
Yeah.
So what do you say to them? Or you'll say, tell them. Tell them about
Just tell them, yeah.
So what do you say to them? Because if you say, I've got PCA, do they understand? Do they say, I've got ABC?
What do you say to them?
I say to them, I've got.
What do you say to them?
I've got a rare.
We're getting more tongue-tied.
Red dementia.
I've got a rare dementia.
Yeah.
And then they look at you surprised, don't they?
Yeah.
Because a lot of people say, oh, you never know. Don't say that. A lot of people say, well, you wouldn't know until you get a bit tongue-tied. But once you get used to somebody and you get your confidence, you can be quite chatty, can't you?
Yeah.
Like you always were.
Nothing changes. That's nice.
And that man on the cruise 2 weeks ago, he said, I still detect a wicked sense of humour in there, didn't he?
Yes, he did.
And most people take really kindly to you, don't they?
Yeah.
They'll go out of their way to chat to you and make you feel comfortable.
Yeah.
It does make a difference, doesn't it?
And the drinks.
That's what I was going to say. How do you prepare for your holidays? Because I see you're sunflowered up nicely.
Yeah.
What does that do to you?
Helps us a lot because
It gets us
through the airport.
I'm not queuing, no. I'm going, yes.
Well, no, you just come across, don't you? You go, excuse me, the first time we were frightened to death, weren't we? We thought we'd been picked out, passport control. What have we done? Until we got through the other side and we realised. So we're just marched in front of everybody, aren't we?
Yeah.
Does everybody use the sunflower lanyards when they go away? Because if you do not, please start using them because it is a game changer.
Yeah. Even at the train station, around town, not everybody recognises it, but it does make them maybe think, oh, something we need to just.
in this country?
No.
Well, actually, that's a really good question because people always ask that. What is your experience when you've gone abroad?
Well, our first experience was Tenerife, I think.
Yeah.
More so than at our local airport in Exeter. And that was where we were singled out, wasn't it? The man, we all got off the plane, in a massive queue, and the man just came across and he went, "Excuse me." That's all he could manage to say, wasn't it? "Excuse me." So that was really good. Yeah.
That's really, really good to
Yeah.
hear. And what else do you take into consideration when you're planning on going on holiday? I mean, clearly a bar. It has to be a bar.
That does focus in a lot of them, doesn't it?
Is there any other considerations that you think this will make it easier for us?
I think the cruise, don't you?
Yeah.
We're new into cruising, and particularly going from Southampton. We've just done one where you fly. We flew to Palma and then joined it, which was okay, but the airport bit's a bit anxious, isn't it? And they're getting on and off the plane, you know, in your bags and.
So do you find on the cruise that they really look after you?
Yes, yes, because at Southampton you pull up in your car, they take your car keys off you, you walk over to the ship with your bag, you're on the ship and you're on holiday, aren't you? And the staff are really, really supportive and really good. They go out of their way, don't they? It's good. The only negative I would say are the toilets are really nice and the assisted toilets, but everything is hands-free. So that's an absolute no-no for PCA.
Yes.
To open the door, you just show your hand.
Oh gosh.
The taps, you show your hand, and of course Nick's.
Yeah.
And the soap, you show your hand. So that's a bit of a nightmare. So we have to go
So we
together.
could design some new liners, couldn't we, really?
Yeah. But interestingly, these two were brand new liners, and I suppose it was in conjunction with COVID.
Yeah.
You can see the idea, but it doesn't work for all disabilities, does it?
Yeah.
And certainly not PCA. That is the biggest nightmare, isn't it?
Now I've got some pictures here of you on the cruise or on your holiday. So you do lots of activities. You keep it fit
What about crazy golf?
and crazy golf.
And keep fit. Oh, and what about, do we ever use the lifts on the cruise?
Never.
We use all the stairs, don't we?
You're always using the stairs to keep fit.
Yeah, so we can eat
Your
more.
fitness goes You've earned your food.
Exactly.
Also, I want to touch on this picture here. Making friends, but meeting friends from your own group. Do you want to tell us who this is?
Rose and Pete.
Yeah.
So it's Rose and Pete from our powder room group, our support group, and we were at Exeter Airport. It was about 4 or 5 weeks ago, wasn't it? Decided on the last minute to go to Benidorm, and Rose came across the lounge and she said, "I thought it was you two," and they were going to Benidorm as well. So we weren't at the same hotel, were we? But we met up with them and we had a couple of days out. It was really nice, yeah, it was good, and so we could both sort of share, you know.
Show a bit of care.
Yes, and a bit
Caring
of
is
support.
sharing, definitely.
Yeah.
That was wonderful.
It was really nice, wasn't it? I'm not very good at selfies though.
That's
But I did manage to rub all the people out in the background.
That's brilliant.
Yeah, it was really nice, wasn't it, to see them. So we thought we might try and organise a holiday properly together.
How wonderful.
Yeah.
Bringing people together, even on holidays. How fabulous is that?
And Pete doesn't have PCA.
He doesn't.
No.
He has PPA, I believe. doesn't he?
Yes.
Primary progressive aphasia, so he has a communication.
Yeah.
So you're his voice and he's your eyes.
Yeah,
It
yes, it is, isn't
works
it?
wonderfully,
Yeah.
doesn't it?
Yeah.
When Pete's there, we go out for walks.
I think you're thinking of John.
Oh yeah.
From
Sorry.
You've got too many friends.
John has got PCA, hasn't he? But
Yeah.
he's lost his sight.
Mm.
And so, yes, when we go for a walk along the seafront, what do you do?
Hold his arm.
Oh, how lovely.
And you guide him along, don't
Guide
you?
him along.
Yeah.
Maybe down the stairs or
I mean,
whatever.
it's fantastic. So, it's still
Hmm.
there, those skills are there, aren't they?
Yes, they are.
There's no, I can't, I just
Right.
have to adapt.
Yeah.
You did try and steer Pete along, didn't you?
Yeah.
But he wasn't having any of it. He said, "I can see where I'm going."
Yeah.
So before we finish, give to anybody?
What would you say, Nick? Do it.
Yes.
It's not easy. It's not always easy, is it? Don't be fooled by the photographs. It's not easy by any means, but it's good to get away, isn't it? And do the stuff that you've always done and just enjoy it. It's time out for both of you. Although, as I say, it's not always easy. But everybody's been accommodating, haven't they? And I would certainly say do it.
People are kind, aren't they?
People are kind, yes, and especially once they know or they realise something's not quite right. People are quite good, aren't they?
And I think that does also reinforce having that diagnosis, knowing and sharing that information with others so they can help you.
Yeah. And definitely I think the earlier the diagnosis, obviously is out of your control, but at least you can put plans into action. I think we had sort of a lot more notice, didn't we, than a lot of people, so get on while you can.
So it's get the diagnosis, get your paperwork sorted, and make sure your passport is valid.
Yes.
Top tips.
Yes, and then just plan.
And just plan, yes. Fantastic. Well, thank you so much.
Oh, thank you. I'm so lovely to hear from Chris and Nikki as well, especially as I get to see them in Devon, because you both come along to Powderham as well, so thank you for speaking today. And in fact, we're going to talk about peer support groups for a few minutes, and often travel, maybe not cruises, not all the time, but travel, maybe visiting families or negotiating trains or buses and things like that, can be a topic that's talked about in peer support groups. So, as Nikki mentioned earlier, we've got 18 peer support groups that we run a month, which is amazing. And 5 of them support PCA. So we have 2 peer support groups for family carers, and we have 3 for people living with PCA. I did ask some of the members of the group this week that I was with, and a member said, what I found most difficult was the loss of status, and the group makes me feel I still have value and that I belong. And that sense of belonging is something that really does come through. Now, Chrissie, I know you go to one of the carers meetings, don't you? The online peer support groups. What does it mean to you?
It's really important because you pick up tips from other people, and you can share. I think you also think, oh, it's not just happening to us. You know, they're experiencing the same thing, and you just feel a bit more normal, because most people go, what? They've never heard of it. It's hard, as several said, it's hard to explain. We know it is, don't we? But it's hard to get into words. And so the online Zoom, you just feel you're with friends, people who know and understand, and we swap tips. It's just really good.
Yeah, that's wonderful to hear. And in fact, they're so popular that we had to split out the carers meeting so that there is an early stage one, and then there's one for families for the mid to late stages. And it is about hints and tips, supporting each other to live well with PCA, whether you're a family supporter or you're a person living with the diagnosis. I'm around all day, so if anybody is interested in exploring attending any of these meetings, please do come and grab me. The slides will come out which explain when they are. So the Living With are on the 3rd Monday of every month, and we have 3 of those groups. Anyway, I won't read it out. And also the carer ones are on the Wednesday, which is the 2nd Wednesday of the month. So yes, please do come and talk to us.
If you've got any questions, it's always the same email, contact@beardimentiasupport.org for any information. We will be giving you all tattoos with that email address on before you leave today, so you all know. But thank you very much, Karen, and thank you so much. I'm now going to to invite Ollie up to speak about the RDTalk, and Ollie actually facilitates the PCA carers group, the mid to late stage one, so he's very keen to have you lot on board and to get involved with some of the research that he's going to be talking about.
Thanks, Nikki. Thank you. What a lovely section that was, to hear everyone's reflections on the group, and you know, everyone is always welcome. So if you are interested and mid to late stages carer, come see me. We'd love to have you. So, but that's not why I'm here today. Today, I'm going to talk to you from my other capacity. So I program manage a grant called the RDTalk grant, and our whole goal in this grant is to evaluate, design, and prepare new ways to support you living with rare forms of dementia, in your case PCA, or supporting your loved ones affected by the conditions. So I'm here to tell you about 2 research opportunities we've got at the moment. That's the same slide again. This is the first one. So it's called the BELIDE trial, which stands for Better Living with Non-Memory-Led Dementias, and this is one for carers, specifically early to mid-stage carers. So it is a web-based program. It was co-designed with 22 people like you, so it's something that's been designed with expert opinion, both professional and lived experience. It's loosely this structure, so there's 3 of them. There's one for PPA, one for PCA, and one for FTD. They're all different. And as you can see in the middle, hopefully, the kind of structure is there's a welcome section, a little bit of upskilling and basic information, some kind of guidance on positive support and living well, both you and the person you're supporting, because that's something we really emphasise in our work with carers especially, is that you can't pour from an empty cup. You've got to look after yourself as well as the person you're looking after. And then we conclude by just making sure that you're signposted properly to various support services that can help you along your journey. So that's this program overview. Now it's research. We have to test whether it's any good or not. We have made it, we think it's good, but we don't get to assume that. We need to make sure. And that means, at the moment, it comes alongside with some kind of stuff to do. So we love a questionnaire. We'll give you a questionnaire before and a questionnaire after. There's 3 check-in sessions with Dr. Ida Suarez-Gonzalez, who's an expert, fantastic PCA clinician, and she'll be kind of taking you through the program. And then, yeah, as I said, more questionnaires at the end. So we're over halfway, so time is kind of running out to take part. So if you're interested, do sign up sooner rather than later. There's still plenty of room, but it's going to only go down, so do that. Now, importantly, what we are doing for this study is a randomized control trial. And what that means is it is the scientific gold standard for evaluating a program. So at the end of this, we will know whether it's any good or not. That's the idea. But in order to do that, what we have to do, within this 238 that we're recruiting, 119 get the program immediately, but the other 119 have to wait. And that's so that we can evaluate the program versus the people who aren't receiving the program. So hopefully that makes sense. So if you sign up, it's not a guarantee you'll get on immediately, but either way, by signing up, you'll be helping us test it, and you might have a 50-50 chance of getting it straight away, or 50-50 chance of having to wait. Okay, that's that. Any more to say on this? Yeah, so it's been really good in terms of what people have told us about it already. People who start, finish it, and people who are then asked to kind of go to interviews to share their experiences of the study, go and give us their feedback, and it's overwhelmingly positive, but not exclusively positive. And when we get this negative feedback, we don't rest on our laurels, we do our best to integrate it and make sure that we're learning from you to continue putting you at the centre of everything we're doing. So I think I do. So as Nikki said, get it tattooed, get it on you now. This email address is the only one you'll need, and it is the point of call for all things. So please do email there if you're interested in that study. And I've got one more to tell you about today, and this is for people living with. So this is a feasibility study. So unlike the last study I told you about, if you sign up for this, you will get to take part. There's no kind of 50-50. and it's for virtual cognitive stimulation therapy. And as you can see, it's for people with 3 different conditions, but that's, as I'll explain later, or do you know, I'll just explain it now. It will be, your groups will be only for people with PCA, so you'll be surrounded by people with the same conditions as you. So, cognitive stimulation therapy is an evidence-based group therapy for people with mild to moderate dementia. It's something that is commissioned within the NHS for Alzheimer's disease, and it's something that until this moment hasn't been adapted for people living with different rare forms of dementia such as PCA. So what we did is we adapted it along with specialists and also people like you. Some of the people in this room may have contributed to its design, and I know there's some people in this room who are going to be in our first wave of groups, which is really exciting. So, as I say, and with all of our research at RDTalk, you're right at the centre of it, and that's really important to us. So, some more details. What does that say? That's just me inviting you to take part, so consider yourselves invited to take part. And this is what it will involve. So, this is an important thing with this because it is relatively time intensive. So, it's something that you'll have to consider when the specific timings are offered to you, whether it's something that can fit into your busy lives. Because as we heard from Chrissie and Nick, you might be on a various cruise or something else. And we encourage that, it's important. But if you can spare 7 weeks solid, right? So it's not every day for those 7 weeks, but you need to have that chunk free. There'll be some surveys, because with all research you've got to do surveys. And then 14 one-hour Zoom sessions, so it's twice weekly for 7 weeks, and then some more surveys afterwards. But that's that core bit, is you've got to be able to commit to twice a week for 7 weeks, and there'll be specific timelines laid out for you should you think about participating. So, if anyone can guess my last slide, I'll be somewhat impressed. It's the contact register support email address. So yeah, please do consider taking part. I'll be around, ask me any questions you might have. And thank you for giving me this attention before lunch. It's very impressive. So I'll free you now.
Without further ado, I'm going to hand over to a very dear friend, John Schott, who many of you will know. He has extraordinary achievements. He probably won't say them himself, so I'll just say he's the Chief Medical Officer for Alzheimer's Research UK, a senior investigator with the NIHR and MRC. He's got more, he's pretty much, he's going for that thing where you cover most, have letters after your name that have every letter in the alphabet. I don't think he's quite got a zoology degree or anything yet, but I don't think it will be long. So he's the bee's knees and a very nice man, and unbelievably good physician as well. And I've been bowled over numerous times by the tender care he's given to so many people, not just with their dementia, but other medical problems as well. So it's a real delight to have him with us. John, over to you.
Thank you. I think I ought to leave now. Can you hear me all right without the microphone? Yeah, I'm quite loud. It's a great pleasure to be here and see some friends and to meet some new people. And I am going to give a sort of an overview, a very brief sort of overview of where we're sort of heading towards with new treatments, blood tests, and what that might mean for PCA specifically. I'm always struck when I've spoken at these events that it's really not ideal to go and talk to a bunch of people, around 50% of whom can't see terribly well, and show lots of slides. So bear with me, and I'll try and explain as I go. I'm also aware that there are some real experts here, people who've been living with these conditions for many years and know a lot about Alzheimer's and PCA, and those who don't. So for those who know a bit more, perhaps will bear with me as we sort of, if things are a little bit simple for you. So the first is to say that the work that's done here at UCL is all part of a very large international group, and Keir, I think, alluded to this a little earlier on and probably said as well, is that we took part in this very large study that was published in Lancet Neurology, which is the top neurology journal, which was a real international collaboration to to understand PCA in a bit more detail. And of course, if you have rare diseases, then you need to collaborate with lots of different centres, and this was, I can't remember, well, we'll come to exactly how many, but lots and lots of different centres around the world, and Keir and myself and Seb were involved in this. And this, the idea was to pull together lots and lots and lots of cases and to try and understand in a bit more detail about what PCA is really about. And what you can see is that this study involved over 1,000 individuals with PCA from 36 different research centres in 16 different countries. And what they confirmed is actually what we described here many, many years ago when we did the first genetic study in PCA, which was the average onset of symptoms was 59, which was actually very close to what our estimates have been before, confirming that this is unexpectedly, looking around the place, a cause of young onset dementia. 60% were women, which probably is about the same proportion as for typical Alzheimer's disease. Seb led the first international criteria, and the second as well, for PCA, and described various different ways of describing PCA. The fundamental one being with what do patients present with, and people presenting with very pure posterior cortical atrophy, so mainly around the vision, make up the majority of these cases. And what's important here is that almost everybody with PCA, 90% plus, depending on how you look at it in different ways, it's due to Alzheimer's disease. So we have PCA being a syndrome which is probably the strongest link to Alzheimer's pathology of any of the syndromes, because lots of people, of course, when you think of Alzheimer's disease, will think of memory problems as you get older. Well, actually, there's lots of causes for memory problems. There aren't that many causes of people having progressive problems with vision, particularly in your mid to late 50s. So when we start thinking about treatments and we start thinking about diagnostic tests, whilst we're thinking about the syndrome of PCA, so why some people get visual problems and get this at a young age, we are talking about Alzheimer's disease as being the main cause. So that leads to the question, and again, this is all relevant for treatments and diagnostics, and what's Alzheimer's disease? And again, we've heard some people mentioning some of these words, and Keir has touched on this a little bit, but the heart of Alzheimer's disease is accumulation of these two abnormally folded proteins within the brain. So there's the amyloid protein, and then we think downstream from that, so after that is the tau protein, and then probably related in some ways to the inflammation that Keir was talking about. In some people, this amyloid, and particularly the tau, seems to spread, particularly in different networks throughout the brain, and that causes brain cells to misfunction, so they don't metabolize as they should do, and then eventually they die away, and we can see the death of neurons in these brain scans, on the MRI scan on the left, and we can see the metabolic profile, so the areas that the brain isn't using glucose, isn't working so well, particularly here, in this section here at the back of the brain, so the posterior cortical atrophy, so the back of the brain, and that leads on to the symptoms. And what we don't really understand, and we're trying to understand, is why some people get memory problems, the majority, amnestic Alzheimer's disease, why a small but very significant and extremely important group here today get visual problems at younger ages, why some people get speech problems, or why they get behavioural problems. We think this whole cascade probably takes over 20 years, which means that if you take a lot of 70-year-olds and you do these sorts of scans to show whether people have got Alzheimer's changes, you'll find about 20% of healthy 70-year-olds have got those changes in the brain. And we think that those people are at high risk of developing Alzheimer's disease over the next 5 or 10 years. So the fact that the amyloid protein is so central to this, because if you don't have amyloid in the brain, you don't have Alzheimer's disease, even though some people will die with amyloid in the brain without Alzheimer's disease. The field, in terms of treatments, has been very focused on amyloid for about the last 20 years. We heard a comment about whether it's all about amyloid. the treatments, the new treatments that we have emerging, and we've had some treatments which many of you will be on to help symptoms, so this is drugs like donepezil or Memantine, we've had for about 20 years. But in the drugs that we've been trying to produce to really alter what's going on in PCA have really been focused on Alzheimer's disease over the last 20 years. And these are of particular interest because 2 drugs now have been licensed for use in the UK, in Europe, one in Europe. They've been licensed now in Japan, in Turkey, in Japan, in the States, in China, so are starting to be used. I'm going to concentrate on those amyloid drugs because those are the ones that have been licensed, but there are about 160 different drugs in clinical trials for Alzheimer's disease at the moment, and 3/4 of those are not targeting amyloid, they're targeting tau, they're targeting inflammation, all sorts of other things. But where we're really at the moment is the amyloid drugs, because after years and years of trying, we've got 2 drugs that have proven to work in very large, very well conducted clinical trials. And these are both antibody-related drugs, so these are drugs that are exciting the immune system to clear this amyloid protein from the brain, and all antibody drugs end in mab of one sort or another, hence lecanemab and donanemab. So these are the 2 different drugs, one made by a company called Eisai and one made by Eli Lilly. So lecanemab was the first one to be licensed. I'm going to show you a graph here, and again, apologies for those who won't be able to see this so well. But this is just to show how effective these drugs are at clearing this amyloid protein from the brain. So this amyloid protein is sticky plaques within the brain. It's really quite remarkable that we can give an infusion through a vein. And if you give a dummy treatment, a placebo, which is in the blue line here, you can see that the amyloid does not change at all. But if you give this treatment, you can see that this amyloid level absolutely plummets. So after 18 months, about 75% of people who started the trial would not be able to start the trial if it was started again, because they don't have a lot of amyloid in the brain. This is actually creating quite an issue, is what do we call people who've got Alzheimer's disease but no longer have amyloid in the brain? And this is a very real issue, actually, whether this is amyloid negative Alzheimer's. Anyway, so the answer is that these drugs are extremely effective at removing one of the core proteins from the brain. Not the other ones particularly, although they do have some effects on tau as well, but that protein in the brain. All very well, but does it work? And the answer is that they do work. So this is looking at rates of cognitive slowing, and this is mainly in typical Alzheimer's disease. So the blue line here is the dummy treatment, and you can see that on average over 18 months people's cognitive functioning declines. But the patients on the treatment, it's slower. Those people are still declining, so this is not a cure, but that decline is slower. And there's lots of ways of thinking about this, and people think maybe it's in terms of 4 to 6 months slowing over an 18-month period. What we don't know is if you look, and again apologies for those who can't see, and the colours are probably not ideal, is that these curves, these lines look like they're continuing to separate. So the question really is, do we get continued separation over time? Which means that if that were the case, and the studies are ongoing, that would mean that these effects get more and more the longer that you go. So we've got a drug that clears amyloid and has some cognitive benefits in terms of slowing. These drugs are not for everybody, so they are only validated for people who have evidence of amyloid in the brain, who have mild disease, and the evidence is that they work best the milder people are. And if you remember, I said there's that 10 or 20 years when you're building your amyloid protein up, and that may be the ideal trial. So there are now trials going on in asymptomatic elderly people to see whether we can clear the amyloid and prevent people from getting cognitive problems starting in the first place. These involve infusions through a vein every 2 weeks for up to 18 months and possibly longer. So this is not trivial. You need to come to a centre, you need to be accompanied by somebody else, and they are very substantial costs. So they're not available yet on the National Health Service. In the private sector, we think they're probably, and I don't do any private work, but they're around 80 to 100,000 pounds a year. So this is very, very substantial amounts of money. They are approved in the UK, and there are people receiving them in the UK. They're not yet available on the National Health Service. What about the second drug? So donanemab. So you'll see that this graph looks very similar when it comes to clearing the amyloid in the brain. The top line is the placebo. There's two different groups here, you can forget about those. Those on treatment, the amyloid load absolutely plummets, and you'll see again, you see very similar changes. You'll see that there is decline in both groups, but the people treated with the donanemab have slower decline, and it looks as though it might be continuing to diverge. Donanemab is given once a month by an infusion for 18 months. Again, has substantial costs. Again, is approved for use in the United Kingdom, so you can receive it in the private sector if you're eligible. It's not yet available on the National Health Service. As well as the inconvenience and the cost, there are side effects of these drugs. And the side effects that we're particularly concerned about are called ARIA, which is amyloid-related imaging abnormalities. It's just a name for this. And there are two forms of ARIA. These are quite, so this is a scans beforehand and this one's afterwards. And you can see that this patient has got these white changes on the MRI scan. That's some brain swelling. And this person here has got some new tiny little hemorrhages in the brain. So these occur in 20 to 40% of people on these medications. In 80 to 90% of people, these are entirely asymptomatic, but they can give symptoms. And there have been a couple of rare reported deaths, particularly when these are mistaken for people developing strokes, and then they're given blood-thinning medications, which is not an ideal thing to be done. So this is not trivial, and therefore this requires very careful monitoring and frequent MRI scans, etc. So this is very much not for everyone, and what we know is that the risk is very increased in people who have particular genetic abnormalities. So people, the strongest risk factor for developing sporadic Alzheimer's disease is possession of this gene called ApoE4, and you can have no copies, one copy, or two copies. And people with two copies particularly are higher risk, which means in this country it's not licensed for people who have two copies of the ApoE4 gene, because they are more likely to get side effects. So these, in terms of who is eligible, so the question clearly you guys are going to ask is can you get it if you have PCA, if you have posterior cortical atrophy. So the first thing is to say is that independent of what sort of Alzheimer's you've got, it's going to be eligible for very, very small numbers of people. Way less than 1 in 10 people will be eligible, even if we could afford it, in terms of the severity, in terms of the scan appearances, the genetics, and so forth. But the answer is I looked up specifically, and these are recommendations for use that have been published in the US. And in the trials for lecanemab, most people had memory problems, but people with atypical syndromes, including PCA, are potential candidates. They weren't excluded, but there's not a great deal of evidence because they weren't tested particularly. And in donanemab, they could be included specifically if people had atypical forms of PCA. So then it's not a preclusion to have these medications if you have PCA, but it's a real question of whether your symptoms are likely to be due to Alzheimer's disease, which is very likely, and whether people are eligible. And in fact, there's quite a big move, and Seb and Keir and I are quite active in this area, that lots of the drug trials are done in people who are a bit older with memory problems, because that's where most people with Alzheimer's disease exist in that spectrum. We want to make the case that people with PCA and atypical forms are often rather good candidates to take part in clinical trials, because people are younger, often a bit fitter, have got their memory, so they can understand a lot what's going on if it's explained to them, particularly in the early stages, and they can remember things, and to try and make it more inclusive, the trials of these conditions. So I said that one of the defining things you need to have to enter these studies is you need to have Alzheimer's disease. And there are new criteria emerging for Alzheimer's disease, which have got some subtle differences, mainly related to how people who don't have symptoms, whether you can define people who don't have symptoms who have these changes in the brain as being at risk or having Alzheimer's disease. But fundamentally, a diagnosis of Alzheimer's disease is made in people who have symptoms and who have, as we discussed, this amyloid and the tau pathology within the brain. Now, of course, most people in this country are diagnosed on the basis of a clinician seeing them, maybe doing some paper and pencil tests, maybe doing an MRI scan, which can't show those proteins. And what we know is, from pathology studies in the States, is that if your doctor doesn't do any specific test for amyloid and tau and says you've got Alzheimer's disease, then they've got an accuracy of about 65 or 70%, which means that around 30% of people will either be misdiagnosed or won't be told they've got Alzheimer's disease when they have. So what we really want to do is to get to a stage where we can incorporate evidence for the Alzheimer changes within the brain with the clinical features, the symptoms that people have, to make the diagnosis much more certain. And we've said this is the amyloid and the tau pathology. And for a long time we've been able to show this using PET scans. This is an amyloid PET scan at the top. So this is, you do an injection into an arm and you go into a special scanner to show the amyloid pathology, and you can see that in red there. And not licensed in this country, but experimentally you can do the same to show where the tau pathology. Here's someone with PCA, and you can see the tau pathology at the back of the brain. Or you can do a spinal fluid test, which many of you will have had, which allows us to measure those proteins. In this country, about 2% of people diagnosed with Alzheimer's disease will have one of those two tests, because amyloid PET is not available through NICE, so it's not we can't use it routinely, and spinal fluid testing isn't available to NICE. So that's really not good enough. So that means only those 2% will ever be eligible for these new treatments. And we've got about 10% of the PET scanners that we have in Europe or the States, and we don't do much in the way of spinal fluid testing. So we need to change this, which is why we need better diagnostics. So there's been a lot of interest around whether we can use blood tests for Alzheimer's disease instead. And for years, this was thought to really be science fiction. So this has changed in the last 3 or 4 years, because of new developments with technology. So these are new bits of kit, and there's lots of them now, which are incredibly sensitive. So they can pick up the amyloid or tau proteins that are made in the brain and are crossing over tiny proportions into the blood. And these are unbelievably sensitive. So if you took a grain of salt and you threw it into an Olympic-sized swimming pool, these machines can detect it. I've done that calculation several times. That's how sensitive they are, and in fact the next generation is 10 times more sensitive than that. So suddenly we can measure these proteins in the blood, which is an extraordinary advance. And now we can measure lots of them, and they've got lots of funny names. A-beta means amyloid, and these ones are all phospho-tau, and there's various others as well. But we're particularly interested in this protein here, which is called, goes by the very snappy name of phosphorylated tau 217, p-tau 217. You don't need to worry about that. What we need to know is, really by complete chance, this particular blood test works incredibly well for a number of reasons. It shows very big differences between patients who have Alzheimer's disease and who don't have Alzheimer's disease. It actually measures both of the two proteins that we're interested in, amyloid and tau. So you only become positive if you've got both amyloid and tau, which is exactly what we would like to be able to do. And it can be measured, and we've done some studies on this, in lots and lots of different commercial platforms, which is brilliant, because then we've got competition, and we've got lots of manufacturers making the kit and driving down the cost and competing with one another. So how does this blood test work? So you can take a blood test, and we have 2 cut points. So we have an upper cut point, and if you're above that upper level, we can say with about 95% certainty that you've got Alzheimer changes in the brain. And then there's a lower cut point, and if you perform below that level, we can say with 95% certainty that you don't have Alzheimer changes. There is this sort of unclear group in around 20% when it's a bit unsafe. So we did lots and lots of studies of this, and I am really proud to say that we have now translated this into a blood test that's available in the National Health Service laboratory at Queen Square now. And so this is some work that we've done here. So this is people who don't have Alzheimer's disease, and these are people who do have Alzheimer's disease. You can see there's a tiny bit of overlap, but if we said that there's that grey zone in the middle, and if we put our cut point in here, then we get about 20% of people, 19% of people who these people have got Alzheimer's disease and spinal fluid tests compatible, and those don't. So we now have a test, and we've done incredibly rigorous work working with our colleagues in the NHS and going across from the university to the NHS lab. And now this test, this is actually available to request in the National Health Service laboratory. We've been available for about a month or so. We do about 300 or 400 tests at the moment, and we've got capacity to do 400,000 tests a year. So we really are hoping that this is going to absolutely democratise diagnosis, because every person who sees patients diagnosed across the country, in memory service or wherever it is, should be able to send a blood test. And a PET scan costs about £1,500 or £2,000, or about, I hope, $5,000 to $10,000 if you do it in the States. And a spinal fluid test requires trained people and costs £300 or £400 minimum. These are about £80 to £100. So it's about the same count as doing a sort of standard blood count. So we now have a test for amyloid and tau that works. And then the question is, can we prove that it works? So we've got a test that we can give, but if you go to your local memory service, they'll say, well, who's going to pay for this? And as you'll probably be aware, things don't get paid for on the National Health Service unless they've gone through the rigorous process called by NICE, which is the National Institute for Health and Care Excellence. You hear this endlessly on Radio 4 in the morning, there's a new drug that's been licensed by NICE or it hasn't by NICE. So we are now doing a trial called ADAPT in memory clinics around the country to provide the evidence that this works. So our aims is to get this as a widely available NHS test and show that its cost effectiveness, so that we can make the case that this should be a part of every single assessment of patients who might have Alzheimer's disease. So what we've done is we've designed a trial, and we want to see how it changes diagnosis, and we're doing a formal clinical trial. So we heard earlier on a really beautiful example of the intervention trial that was being run through the support services, which was that 50% of people get something now and 50% get it later. And we're doing exactly the same thing. So the idea is here, and we're running through the clinical trials unit, is that we're going to recruit 1,200 people, 1,100 people from 20 memory services, and they'll go through their routine, whatever the clinical services do. The difference is that at 3 months, 50% of the people, the doctor will receive the blood test result, and the rest will get it in a year. So we can then see what is the impact of being given that blood test in terms of your diagnosis rates, how you feel about this, whether you need other tests, whether you get offered treatments, whether you get offered clinical trials. And so we're having all of the blood tests sent to our neuroimmunology lab, but we're also really embedding a huge amount of work. We've got a dedicated public engagement stream here, so we are, as well as an education piece, so we've now got a tool to educate clinicians, doctors, how to use these tests. But we've also got a big stream of work from the universities of Kent, particularly, which is doing semi-structured interviews with participants and focus groups to say, for doctors, how do you interpret these tests? What do they mean to you? But participants, what's the emotional impact of having a biomarker diagnosis? Is it positive or is it a negative? What's your views about the future? What's the impact on relationships that you have with your doctors? How does this really impact? And then how can we make diagnostic pathways, and we're working with the London School of Economics around healthcare outcomes to show that this makes a real difference. So we're going really across the country. Actually, we're extending much further than this, so we're now actually going up towards Scotland. So we're really hoping to go, in fact we've got more centres now than this, so we'll have, we've got people falling over themselves to take part in the clinical trial. So, and we hope to get going very, very soon with that. And before we've even started, you may have seen there's quite a lot of interest in the media. I wasn't sure whether it was more interest in blood tests helping to spot Alzheimer's or that you wouldn't date a Tory. I'm sort of quite proud that we got this in together. And there's a huge public interest and appetite for that. So I'm going to just acknowledge the people who have been doing all of this work around this blood test. So, we've got our core team. These are people in the lab actually doing the translation. And then we've got old age psychiatrists who are helping us design this study. Then we've got people leading our PPI group, and we've got our team from the London School. We've got our colleague who's doing some PET work with us, and then we've got our massive clinical trials team as well who are running all of this. I'll stop there, but I hope I've given you an idea of where we're at and where we're moving towards improving diagnosis of Alzheimer's disease, which will be relevant to everyone with PCA, given the very close link between PCA and Alzheimer's disease, where we are with treatments. And I will just add with the treatments that whilst I hopefully have given you some excitement about these new treatments, many of you quite rightly will be daunted about costs, access, all those other things. This is just the start. There's a new generation of amyloid treatments, which is now in trials, which looks to be quite effective after just 3 doses and at much smaller levels with much fewer side effects. We've talked to people here who are in clinical trials around inflammation, around progranulin, around tau. This is, we really think that this is the moment for Alzheimer's disease that we had for stroke a few years ago, when we had the first clot-busting therapies, which were only available to a few people and were quite dangerous. And now we've got services that are delivering them, or the first HIV treatments, or the first cancer treatments. And what we've seen is a huge influx of investment from pharma companies. The government have invested £120 million in a network to try and move this further forward. The Dementia Trials Accelerator, which many of us are involved with, the Dementia Trials Network. Real interest and investment in this, so this is a very fast moving field. And I think the blood tests, again, which are focused on Alzheimer's disease at the moment, and now focusing on other forms as well. And so we really are at a turning point when we understand the diseases enough. We have ways of diagnosing at scale, we have treatments coming, and really interestingly is that we'll move into the pre-symptomatic phase and hopefully think about that we can screen people at risk and treat, like we do for breast cancer or cervical cancer or colon cancer, pick people in the early stages and treat and prevent. So that's where we're headed. Thank you very much for your attention.